The setting of global space travel allows for so many good lessons to be taught. We need a human in charge? Bullshit. We need a fucking computer in charge.
They don't know what I know.
Okay, welcome back to another engineering podcast. I'm Adam.
I'm Brian. Damn it. I even tried to say it differently and it came out the same way.
If we were to strip away the purpose of that introduction every time, it would be, and this is the voice of Adam.
Oh, and this is Brian's voice.
But the real purpose is just so that they, know who's who based on the voice at the introduction. It doesn't matter which one of us is which for the purpose of the experience you're about to have right now.
I've never thought about why we do it. That's a good reason. That's a good reason to do it.
Oh, but thanks for coming out for another one. And thank you to all of our new. We're growing pretty fast. It's really cool. So thank you to everybody.
You could say we're exploding.
Who's new, checking it out, blowing up, son.
I think you'd be exaggerating.
And especially special thanks to our Patreon backers who lighten the load on us a bit financially. If you hop in there with just like $1, you also get access to our secret group on Facebook where we talk about things.
And don't forget that we have like sick ass mugs and t-shirts that says engineering on them. And if you have ideas for shirts that convey that fun idea, because that word's really cool, and you want us to make another shirt, let us know and we can like make some cool shirts or something.
Right.
Because
all we really have dialed in there is like the process to get an idea on a shirt and then make it available.
We got to make that hat that Jess requested after our Trump episode or our political episode.
I forget what it was.
It was just a hat that says Elon Musk on it.
Oh, yeah. Elon Musk.
We were promised one purchase and we make that hat.
Okay, so this is part 2 of artificial intelligence.
Part 2.
Where I think we probably got a guest episode in between.
Yeah, we got episodes just like stacked up right now.
The thing about guests is it has made our record to release pipeline a lot less linear.
And a lot less burdensome because like we have to do those when guests can. So we're ahead right now more than ever, I think, which feels good.
Dope. But also, so part 2. So I feel like we should recap part 1.
Yeah, so this is part 2, artificial intelligence. What did we talk about in part 1?
Part 1, I feel like we tried really hard not to make it a philosophical conversation about what is intelligence. We backed up to things like calculators.
Yeah. And tried to stay out of the rabbit holes in episode 1 and just sort of define it a little bit. Like what is it?
But what we really got to is a very Zengineering sort of core, which we really weren't aiming for this time.
Yeah. That came out of it by accident.
What we realized that the first piece of this is about knowledge. It's about like what we humans built, whether it was our direct intent or not, was this communication network that we've talked about many times that essentially makes the entirety of human knowledge and human memory accessible to anyone.
We coined a cool term. We coined the term artificial memory because that describes most of what we've built as humans that we think of right now as like computation and like the internet. It's just memory. It's just, we just take ideas and pictures and concepts and definitions and facts and put them somewhere where we can look them up later.
Was it that episode or one of our other attempts to talk about this very topic?
We might have coined it in other variations, but
when I talked about history,
you've coined it now.
Like the idea that history, like if you think about what we know about the Romans now, it's all sort of pieced together from the details that we can get and some written accounts that persisted poorly and what we can find through archaeology and what we had for artificial memory. Like in 3 generations, when no one that ever remembers me, that knew me personally or was connected to me personally is gone, they're not going to have to do archaeology to understand things about my life. I'm wearing an Apple Watch. They could know exactly what my heart rate was January 28th at 5:05 p.m. Pacific Standard Time.
They'll know.
If they wanted. fired up about artificial intelligence.
So episode 1 ended up being about artificial memory, which is interesting because in our attempt to kind of define what artificial intelligence is, we ran into a problem finding intelligence in things and ranking intelligence. And so we had some interesting quandaries. Like, for instance, is intelligence actually a thing or a made up concept? So in any case, this episode is kind of about, we're going to try to do artificial intelligence as it is now, kind of in our modern lives right now. What's going on? How does it work? Where is it?
Well, what we really promised at the end of that episode was the floodgates, right? Like it ended up with us, like the relevance, what we're trying to get to here is to help you understand the problems, how we've progressed through them, and then the things that are happening right now technologically that are the floodgates, and why it's like we're about to hit that point where the conversation goes like mind-blown territory, right?
We were talking about why this is important to talk about, and we had some really good points. This was in previous attempts at this episode, I mean. And one of them is just that we did this artificial memory component, which doesn't really have, arguably doesn't have like its own external effects. Like, we're just storing information in a book, and a book sits on a shelf. But now we're taking the next step, and we're making artificial intelligence. And so where we kind of felt like the transition there was the transition between storing information and then acting on information. And so now that we have artificial intelligence coming online in dozens of places. I mean, we'll get to them in a minute, but like everything you interact with all day has artificial intelligence behind it. Now we are offloading.
Like, it's offered as a service for pennies. You can get intelligence from Amazon Web Services and incorporate it in your product. We've
offloaded memory to computers. Now we're starting to offload the action on that memory. And so we have things like self-driving cars coming online that are driven by computers, and all the decisions about them are made by computers. And it's important for us as a society to understand how those technologies work as we replace more and more human stuff with them. And so I think artificial intelligence is dangerous if we don't understand it, if we don't address what it is, and we pretend like it's not in everything that affects our lives now.
Like, you mean understand like where it came from, how it works, like fundamentally, like what are the computational processes that are happening for this decision to be made, so that we can trust that decision once we've offloaded something way more complicated, like
trust it,
international diplomacy,
guide it, make policy about it. Like, it's
right.
It's very important. It's something that is going to, and it's also something that is going to come so quickly that if we ignore it, it's going to pass us by.
And I think the funny place to, but so the first, and I think interesting piece that I like, the story I like telling about this part of the, like, where we are in the sort of progression of this, and why it's a very fascinating time, comes back to, like, why is it that in just the last 3 years, suddenly there's this, pop culture is the wrong way to say it, but it's more like it's sincerely regarded by popular culture, whereas it used to be a fairy tale.
Yeah, I like to say that 100 years ago, things like artificial intelligence and robots and self-driving cars were just fantasy, right? A few people were thinking about them. It was a fantastic idea. It was never going to be reality.
Right.
25 years ago, it was purely in science fiction. I mean, movies, Star Trek, Star Wars, books. Now it is reality. Like, these things are really happening. Computers are making decisions. Computers are making medical decisions. Computers are making vehicle decisions and policy decisions. And so it's no longer the realm of, let me just think about it. It's the realm of, this is affecting me every single day. I need to be aware of it.
And what's really, really interesting is that the thing that brought about the rapid acceleration in this sort of field of study or computation or whatever you want to call it is video games. Like, what? Especially because I feel like video games are largely regarded as a lark, as an amusement.
Ooh, lark's a good word.
As a thing to distract you from reality. And what we did with video games is we actually built a reality generation engine.
Yeah, that's the funny
Right.
thing is we built. What's the earliest video game? When you think of early video games, what comes to
Pong.
mind?
100% Pong.
The two lines cruising back and forth on a screen, bouncing a ball like a fake
Which was,
dot.
even at that level, an effort to reproduce reality. They were trying to simulate the experience of playing ping pong.
Ping pong. Beer pong? Was beer pong invented when ping pong was invented?
Flip cup.
Do you think there's a flip cup app for your iPhone?
There's got to be.
Do you flip the iPhone? Because it would know.
But, well, so what's funny is, what I would say is that they're trying to reproduce the experience of ping pong. But video games from there went through this sort of swing of it just sort of being different versions of checkers. You know, the same. They were frivolous, right? They were not particularly like
the
Pac-Man.
The video games that most of the world experienced until like 10 years ago were like the games that come on Windows computers for free. They had like Solitaire and Checkers, which are kind of lame, right? Because they're identical to the offline version. They just happen to be digitized so you can sit at your computer and play Solitaire. I guess you play Solitaire by yourself anyway, but Checkers by yourself, which I get why that always kind of had that air of like, video games are kind of dumb. But now the whole world is engaged with games. Everyone has, or at least like interactive for fun things that are digitized on computers. And so it's definitely not just isolated to the realm of kids who had computers and were fascinated by them like it was when we were kids.
What was the first person shooter you remember?
Oh, man. I started with Wolfenstein 3D.
Yeah.
And like real early first-person shooter that it was 3D only in the sense that like the graphics on the screen kind of looked like you were actually walking through like
through three-dimensional space.
Yeah.
But the graphics were real shitty.
And it was we lived through a really interesting time with those video games because there was this major explosion of software and hardware that was specifically focused on the games. All of a sudden, I was upgrading my computer to play games, which was not my intention as a kid. Like computers didn't play games when I first got my computer. I was just interested in it. I mean, they had like text-based games and stuff, but then of a sudden, within a few years, you had to upgrade your processor and your memory, and then all of a sudden, this new thing called a video card every year if you wanted to play the video games that were coming out.
You needed a card that was more specifically built to handle the processing for these games in this sort of three-dimensional.
Yeah.
Like at first, it was just to handle three-dimensional space. Then physics was a big thing. And then like what we were chasing every time one of these, Quake and then Counter-Strike. And then like as we progressed through these games that we've now been playing our whole lives, what was it that kept getting better? Particularly in first-person shooters, which are wildly popular.
Yeah, it's an interesting question because video games a lot of them have kind of been identical since we started. Like Mario, everybody thinks of Nintendo and Mario. I think when they think of video games, or so many people do. It's such a prolific, iconic game. And the Mario game that I was literally playing like before we started working on this episode today is basically the same game I was playing 25 years ago. It's still just a little dude running side to side on a screen and jumping up and down and collecting coins and stomping on turtle birds and stuff. And the thing that's changed is it's become more real. It's become more organic. Like when the original Mario game, I remember this was partly because I was a kid, but partly also because I used to get really angry at it all the time because you'd like hit the button and it wouldn't register that you hit the button right, or it would feel like it was half a second off, like computationally it would freeze. There were things that didn't feel right. The new game, like the little character skids on the screen, the like jumping arc looks a little more like real gravity. Things are smoother. The graphics, Mario in particular is still like a fake world. It's a fake 2D screen, but the graphics just look a lot better. You can tell it just feels more real. It feels more organic. It feels like I'm in the world more than it did 25 years ago. And that's the same thing that's been happening with the grander games that are now, they look like reality. I mean, NFL 2017 or whatever looks like you're watching a real football game when you walk in the room.
And I think, and so the chips, the computational capacity that they've been developing has continued to progress, and it's been progressing, chasing like physics, right? Like it's, and visually speaking, it's been chasing, how do you produce this image that feels more like reality? Like the other thing I think that's important to understand about how that processing works, your game, the video game lives on a CD or on a hard drive as a set of instructions that are like, here are the parameters for this world, and here are the things within that can happen. And the GPU is on the fly processing all of that data to produce what you're supposed to see at any given moment, based on all your circumstances, all the physics, how the light bounces, how the camera is supposed to be. So you can see it, and then as soon as you move past that data set, it's gone. Like, it doesn't persist after you walk past it. Like, that bush that you were standing next to
Can't.
it's just gone. It doesn't, it's back to being just a data set on a hard drive.
There's such an interesting this immediately takes me to the classic philosophical question of, if a tree falls in the woods and no one's there to hear it, does the tree fall? Does the tree make a noise? And it's interesting when you look at video games, because especially modern video games, and when you take into consideration, like you mentioned a minute ago, that they're like physics engines. Like, there is a component in a video game that explicitly just reproduces the physics of our universe so that the game seems real. When you jump, you look like you're jumping. It's just a piece of software, and I think it's hardware now too, explicit, that just calculates physics. How do things explode? How does lighting fall on a building? How does water ripple? And we've reproduced this reality in the game, but there's still this constraint where we say, well, if the character can't see it, why would we render it? Why would we waste time? Why would we waste computation rendering a tree that's outside the house you're in? You can't see it. And so the game doesn't. And so it really makes me think that the universe isn't doing it either.
Right. Yeah. It's funny because it gets us back to that same philosophical and just weird, like simulations theory thing. But to back away from that, the reason that I push that envelope in terms of falling off the philosophy conversation cliff
is back.
Because you need to understand the type of device we've built that, and this is why I think it's so cool, is because basically in the last few years, we've started to chase things, the stuff we were talking about in the last episode. And the real floodgates for me was realizing that if you use GPUs, if you use those video cards, those reality engines to process this behavior, that it's way more effective. This is you said it at one point when we were talking to Alan about quantum computing. You said fractals are sort of like how the universe, it's like the computation mechanism for the universe. And you're talking about the same kind of math. If you're trying to make a bush in a video game look better, you're chasing the same.
Yeah.
You're chasing the same math.
You know what's really, really good at rendering reality, like absolutely perfectly?
The universe?
The motherfucking universe.
Right? But no, but so that's, to understand the overlap is important, because what happened recently is that they've realized like what we're chasing as we try to build these tools for decision making and not just knowledge, not just memory persistence, is we're treading in the same space as the universe is when it reproduces another tree. So I feel like I wanted to get to that GPU thing and video games, because it's important to understand like that this obsession with amusement and with just like, we were again driven whilst not paying attention by some sort of external force, it almost feels like, to create this tool that now we're suddenly going, oh wait, the thing that makes the video game look real good is actually really good at helping us solve this other problem, which is essentially the problem that we were talking about in the first part of this.
It's the transition from episode 1 to episode 2. It's what do we do with all this information now that we have it? We've captured the world's information.
That's Doom. That's Counter-Strike, right? Assassin's Creed is the answer to how we figure out the universe.
Yeah, I mean, if we had looked at it from the perspective of where we kind of end up by accident all the time of everything humans seem to be doing is an attempt to reproduce reality in some capacity.
Connect
It would have made perfect sense. We built a component of a computer explicitly to reproduce reality more efficiently, and now all of a sudden 3 years ago, the big chip manufacturers realized, hey, we should be producing these for big data analytics, for neural networks, for machine learning and artificial intelligence, and now an explosion of a whole different level of processing power for something that we built for video games.
We hit this point technologically where we suddenly have the computing capacity because we love video games to solve this whole different type of problem that is, what do you do with all this knowledge? How do you process and synthesize answers from all this knowledge?
Mm-hmm.
But I feel like we should back up to like where we are right now in that process,
where is it?
and like what science is happening.
Where is artificial intelligence in our... Where else is that in life? I mean, there are a whole bunch we could list off. What other things do you think of in that space?
I think the reason I struggle with that question is because I'm trying to think of actual applications, right? I mean, the real answer to where is AI, it's in what your ticket costs. It's in what your groceries costs. It's in the way the stock market behaves, because that is entirely run by algorithm now. It's in the reflection of the economy that they talk about on the news. It's in everything now.
Those are all very interesting answers to that question, because it's kind of a different perspective on it. It's not like where are we building artificial intelligence systems necessarily, but it's kind of like where has that artificial intelligence emerged in like these complex systems that we no longer really have control over. It's a different.
I'm thinking,
it's a totally
like, where do
different
I find a number that I know that a person didn't go, you know, that ticket should cost $512 right now, and in 5 minutes it'll cost $517. Right?
That's
a person didn't do that.
Right. Yeah, and that's a good way to look at this, because it's not just where we have computer scientists classically defining what is artificial intelligence. It is these things where we're offloading these decisions. We're taking massive amounts of information and we're calculating things in real time to publish, for instance, prices of tickets online, prices of goods, prices of commodities, prices of stocks. It's all done by computers now. And whether or not it's in that gray area of, did a person put a really complex decision tree in there, or did we kind of entirely offload the decision to the computer? Again, we're in a transition period. All of that is intelligence, is artificial intelligence as far as I'm concerned.
Right.
Southwest plane tickets, hotel room.
Oh, right now it should cost this much, right? Like there's some sort of algorithm that has learned from patterns and is trying to make the most money it can possibly make off of you at any given moment based on a shitload of data analysis.
And you'll even see that within a few minutes, right? You'll be looking at a ticket price and you'll go browse another site to compare, and when you come back, the price is different. That's a artificial intelligence making that decision.
But I feel like that's way deep. Like that's the kind of artificial intelligence we pretend doesn't exist because it's weird.
Well, it's deep because I don't think I wasn't even thinking about stuff like that as artificial intelligence. I was thinking from a technical perspective, like what is the technology underneath? Do computer scientists call that artificial intelligence? But you're totally right. Like that is, we already offloaded the information. It has the artificial memory. Now all of a sudden it is making decisions. We've let a computer make the decisions that a human used to make. That is the intelligence part. That is the thing being conscious. That is the thing coming into, it's alive and it's making decisions.
A decision, right? Let's strip it way back to, I'm going to do this thing or I'm not going to do this thing, right? Forget the vagary of what number between one and whatever am I going to put in front of this person as the price of their ticket. What would you classify in the context of the ticket price as a good decision versus a bad decision?
A good decision would be the exact maximum price that the consumer is willing to pay at that moment,
whilst not being scared away because it's too expensive.
Right. I mean, it's the max, right? It's the exact amount that person at that moment, which has so many things come into play, right? Like if that algorithm all of a sudden has access to my Facebook feed, it might know that I'm fired up and just got a bonus check. So it should bump the price up, you know?
Right. Right. And so, I think where I was going with that is it's relevant to understand, because if you want to understand, and this goes back to, we talked about it a tiny bit when in the hit list episode where we talked about the algorithm that plays Go at a world-class level now. Mm-hmm. Like part of what they're doing with machine learning now is instead of outlining instead of processing a giant quantity of data, like it's processing what the best price for a ticket to put up right now is, but it's doing that based on what tickets have sold in the past and a massive trend analysis of the back, like of that artificial memory that it has of how people tend to behave on that service at any given time, whatever, right? If you can add that layer of also this person is feeling this certain way, you now have this new meta layer on top of how could you give this person the best price? And this is where we get to things like Amazon's pricing, right? Because they're starting to toe into things like actually paying attention to what you're up to beyond just this tends to sell at this time.
Yeah.
But the thing about so where it kicks back to that Go thing is the way that we've been, and this is the fascinating part of machine learning, I think, is the way that we've been teaching computers to do that is by, instead of saying, like, what we do is we take a computer made mostly of GPUs that are really good at this sort of geometric, sort of like fractal, this math that's based on try a bunch of stuff, commit some extra resources to the stuff that seems to work, continue following that path. And we tell it, the point is sell a ticket. If it doesn't end with the ticket selling, then here's how you rewrite your code. And if it does, then here's how you rewrite your code.
The couple concepts that people have probably heard is the term machine learning and the term neural net. And for the most part, I sum those up as just, it's the same process a human would do to solve those issues. Like, for instance, say a human had to just classify sentences as positive or negative, right? Is this sentence like happy and positive, or is it a negative sentence? Does it say I hate someone, or does it say I love someone? The way a human would do that is they like read it and they look at the words and they kind of take the context into account, and then they classify it. But when you go to the next step where you have to have a person tell a computer how to do it, you have to kind of reduce it and say, well, if it has the word love in it, it's positive. If it has the word hate in it, it's negative. Maybe you go a little further. Maybe you say, well, if it has the word like in it, it's positive. If it has the word rainbow in it, it's positive. But you quickly run out of the ability for a person to do that. And so really what modern machine learning is just giving all of that information to the computer.
I think a term that you might have heard that's important is reinforcement learning. What GPUs and a lot of this stuff has allowed us to do is write an algorithm, which is just a set of instructions for a computer to take part in what's called reinforcement learning. And what's crazy about that is we used to teach computers how to do things, if you want to call it teach, by explicitly writing the code. If this scenario happens, then here's how you react to it. And this is, and that's what you do. If it falls outside of those parameters, you got nothing. There's no, you return a blue screen of death and everyone's grumpy. How humans learn to do things is reinforcement learning. Like the reason that intern can read the sentence and go, that's good, tick. That's bad, tick, is because they have learned language and they've learned that there are words to express sentiments that are these emotions that they feel. And you learn that by growing up as a kid. And it's, you burn your hand on a stove and you go, that was bad. I didn't like it. And somebody goes, that's called pain. And you go, okay, pain. Now I have this whole set of concepts around this idea of pain, bad, hurt, all that kind of stuff. And previously we could tell a computer, if any of these words show up, then that's negative. The thing we can do now is lead a computer through the process that we went through in order to gain this weird, broader sort of knowledge plus intelligence plus context definition of what bad or what pain is, that is way more nuanced than, like, this just has all these shades of meaning to it that you really just can't generate unless you handhold the entity, whatever it is, computer or child, through that.
Well, what we do is it's exactly what you were just describing. And we still kind of, as humans, want to draw a distinction between it. But what we do is we just feed we have all this information. We've offloaded it all to artificial memory, and we can now dump it on that computer, give it the same constraints you would give that intern, and say, go classify these things. Here are constraints. Here's prior information. Here's a shitload of prior information. Like when you look at self-driving cars, for instance, one of the reasons Google got into the map game was because the reason they have all that imagery of the whole planet is because they're gathering information to feed into cars to allow them to drive themselves. And so what we're doing is the same thing we do with kids. We just feed a bunch of information into a kid's head and make them a very good decision maker. And so we're just doing the same thing with computers. And it all comes down to just computation. It's just algorithms calculating this stuff and looking for trends and looking for patterns. And then we give it positive feedback and say, hey, you identified that pattern correctly.
Good work.
Great job. Right. Good job, boy. Thanks for fetching the stick.
And that's reinforcement learning. Like literally the people that are working on these algorithms sit around and they go, that was good. That was bad. That was good. That was bad. About the performance of this computer. And then it rewrites its own code to adapt to the algorithm, which is no different than your brain rewriting your behavior patterns based on the input you were given as a child or on an ongoing basis.
It's interesting to really, I find it interesting to know in the depth of how this stuff works at the level we're talking about it right now, just because it so clearly mimics what humans are doing in making decisions. And for me, it just makes that line more blurry between what is making me different, what is making my decision different from a computer that just has access to the same information.
And this is what's crazy about the when you do that, along with memory that is not faulty, like we have as humans.
Very, very fault-laden memory.
Then you build a thing where like that algorithm that can win at Go that we talked about in a previous episode, through reinforcement learning, rewrote itself such that it's never beaten at Go anymore. And it never will be. Like it's because it figured out everything there is to know about Go, encapsulated in an algorithm that is persistent with digital fidelity in the hard drive where it resides now, and you don't have a human with all their dumb baggage clogging it up when it tries to play against the human who has all its dumb, I'm sweaty now, and that distracted me, and that girl just walked by, and now I'm distracted again, and then
phone's beeping at me.
All this biological baggage is not attached to this algorithm. So it's like, when we say that we have a computer that's better than a human at chess, it's not sometimes, and it's never a thing we're going to go back from unless that computer is obliterated and its data stores are obliterated.
Yeah, the Go game especially was particularly unique because of what you were just describing. It literally taught itself how to get better. It was learning how to play better. It was the early chess computers were just computational. It was just, hey, we've invented this computer that can calculate moves quicker.
It looks at every possible option every time.
It was an interest. The thing that's really interesting about chess and Go, especially because Go is even more simplified. It's more complex, but the rule set is simpler. The thing that's neat about it is it's like exponential complexity as you go from next turn, 2 turns out, 3 turns out. And so even though a human can't think about every potential move, even in the next move, one move away, humans are, for some reason, we're very good with these games about strategically thinking out and ignoring the stuff that's not relevant. Whereas a computer just had to calculate every potential move for the next move and some layers of other intelligence. But so initially these chess computers were just brute force. They were just like, hey, I'm trying to think faster than you. And over time they thought a little faster and faster. But this Go computer taught itself to get better. It taught itself to not only could it compute more, but it was learning the rule set. It learned the rule set itself.
And that runs through the reinforcement thing that we were talking about. And the cool thing with games is they're pretty easy to reinforce because you either win the game or you don't. And so for a thing like that, you can just go, well, here are the rules. Here's, what's to be learned and what's not, and just go run. And then you have an algorithm that can win at Go. What I think is fascinating about that is, my understanding at least, is that they don't really know. It's back to that black box problem. Like, they don't really know what's in that algorithm exactly. It's a program that's really good at playing Go, but it's not like a person has pecked through every piece of that code to say like, oh, here's what's going on now. Like in this case, they might not have. But we're nearing a future where there's going to be too much code to go through.
Well, it's interesting because it's not, in a lot of cases, it's not even necessarily like code per se. Like you think of like code on a screen, it's just a bunch of variables that the system has defined for itself, and it massages them. And so it's like, let me sprinkle a little bit of this decision and a little bit of this decision in, and if it plays well, I'll keep that balance. If it doesn't, I'll adjust that and sprinkle a little more next time. Kind of the same way you cook.
And also
like,
remember the outcome of the previous situation so that I can use it the next time it bumps into something else.
Some really cool videos that people can look up, and we'll try to post some links for this, are you can look up videos of like artificial intelligences. That didn't sound like the right way to say that. Artificial intelligence learning to play like Mario, like old school 2D side screen game. And you'll watch these computers. It's weird at first because you don't know what's going on. You're like, what's happening? But the computer will play the game, and you'll see Mario just run into the turtle and die. And then they'll speed it up, right? So this will be like a 5-minute video of actually like hundreds of hours of gameplay. Next scene, same thing will happen. He'll run in and die to the turtle. The next scene, you'll see him jump over the turtle, and you're like, wait, what just happened? And then over a period of a few minutes, you'll see the artificial intelligence play that level over and over and over again, and learn from its mistakes and learn the rules of the game. And then all of a sudden, it plays it perfectly, hops on every single bad guy, and gets to the end without dying. And it's almost so incredible that you can't register what's happening. It doesn't make sense that something's learning to do that without something else telling it how to do it.
Or without going to that space of realizing that that's what humans do.
It's exactly what humans do.
Because if you go, oh, well, it's no different than a baby, then anybody goes, oh, you're right. But that's weird.
Well, I think we're to the point where we've got these things that are artificial intelligences in our lives right now. And like you mentioned, maybe in the last episode, I've heard you say this a bunch, like once it becomes a functional thing, we no longer label it as an artificial being. It's just a tool that works right. Like when you're on Amazon shopping, or on any shopping site these days for the most part, if you see the things that it suggests you buy, those aren't just there by chance. Those aren't just randomly pulled or just pulled because they have the same word in their title. Like, that's artificial intelligence. It's looking at the whole history of everything you've ever bought and what you click on and what you're clicking on that day. And it's making decisions to show you this album that you looked at 3 months ago because it's the anniversary of that band and it knows that you're interested in it.
So what's happening is people are writing a baseline algorithm for this reinforcement learning. Amazon is one of them. And then they're saying, as a service, we're going to offer you the ability to incorporate a massive computing mechanism into your product that will pay attention to what this user is doing and start to write an algorithm based on the reinforcement or the negative or positive reinforcement that it gets, to begin to craft an algorithm for how I should do X, when I should remind you to pee, when I should, what price I should make a product at what time of day. Like, they already know that people in general are more likely to buy something after work when they're tired and they're bored and whatever, right? When you apply a machine learning or an adaptive layer like we just described, like that reinforcement layer on top, now you have what I was talking about before, which is a thing that can literally go, you're sad right now. If I hit you with this product, you're more likely to buy it. I know that about you, and I'm going to use it to make you buy stuff. right? Like they're already selling that as a service, that type of thinking as a service, which tracks with the same thing as those video games. If there's money to be made by leveraging this technology, there's no fucking way it's going back in the box.
Well, that always is what drives technological advancement in our economic system, because it's a capitalistic system,
but not
right?
for
And
monkeys,
so
and they seem to do the same thing.
Well,
right?
No, their existence is capitalistic too, right? They want more bananas. They want more women. You know, it's the same. It's the same bullshit.
Right.
Different species, right? So,
there's our shirt for this
that is a good
episode.
shirt.
Same bullshit,
Yeah.
different species.
Definitely, we need like a guilty looking monkey
Yeah.
face on it. There's so many applications that are happening for this right now. I mean, IBM Watson is a famous AI that everyone's familiar with right now. Is the computer that IBM built that won at Jeopardy against like the 3 greatest Jeopardy winners of all time. It crushed them. And again, it doesn't always seem, because of people's day-to-day interaction with their computer, they're like, oh, well, I can look up any piece of information on the internet too. It almost didn't surprise people, right? It's like, oh, well, Jeopardy's just looking up information and answering a question, right? Like I can do that with Wikipedia. But this was a computer understanding Alex Trebek's like clever quips and the confusing categories that were abstract thinking, and looking up information and answering these questions and doing it quicker than all 3 of the greatest Jeopardy winners of all time. And so IBM Watson, if you go to their website, it's so interesting. They're using this for all kinds of things. And one of them is medical. They're using Watson. They've fed it tons and tons of academic research and data from all kinds of studies, human studies. And now it's making all kinds of predictions for medicine. Someone comes in with a sickness, a classic place where the battle between the doctor and like data it's been a classic battle for decades now. These computers are making much better decisions on some things. Some things are still way better with the doctor, but
I'm pretty sure that for the last 5 years or so, we've had computers that are better than radiologists, which is a harsh way to say it. But like what you're doing as a radiologist is looking at an image and trying to find like you're looking for a subset of patterns that you recognize are not biologically, like they don't represent the biology of what should be in front of you.
Well,
within the last couple of days, they just announced that there's some algorithm that with like 100% certainty now is better at detecting cancer from the scans that we're able to do than humans are. And it's just pattern recognition. It's actually not anything fancy if you break it down.
All humans are pattern recognizers. We're really good at recognizing patterns and then repeating patterns. And
cancer is just an out of control pattern replication in a cell.
Yeah, I mean, we've had the concept of triage for, the original concept of triage was like wartime on a battlefield. Is this person going to die? Is this person going to be okay? Or is this person need immediate medical attention? But we've had that same concept applied more deeply in hospitals for decades, where it's literally just a decision tree for doctors to follow. And it typically resulted in better results for patients. But we've been so resistant to it because it seems so stupid that a list of decisions on a wall is going to do better than someone who studied medicine for 50 years. It seems so stupid to us. But this is the thing that we need to come to terms with as a species, as artificial intelligence consumes every aspect of our life. Like we need to understand it and appreciate that it is doing a better job on certain things, and it's going to continue to do a better job.
And I think part of that is understanding what this whole part 2 was about, right? Which is getting us to that, how the technology works to facilitate this parallel computing that allows us to do reinforcement learning, and then to understand that once you've crossed that hurdle into reinforcement learning, you're doing exactly what a human does. And so if they say they have an algorithm that has learned to detect cancer from images better than a human, they're right. They led it through exactly the same process that a doctor is doing
more
with none of the bullshit baggage. It's not also worrying about its divorce. It's not also worrying about its children. It's doing nothing but applying the exact same decision-making process that a doctor is based on all the data you can possibly have. It was taught in the same way, step by step, that a doctor would be for looking at that thing. And it knows.
It's just able to do more, and it's able to improve now. And a huge part of it, one of the really interesting components here is that machine learning is really kind of just a product of the technology getting better and faster. Computers just keep getting faster and faster and faster. And we do have like incremental adjustments as we come up with new technologies, like moving from a regular CPU to a GPU. But they're just getting faster at things. And so it can just look at more pictures of cancer that we have in the past recognized as yes, that was, or no, that wasn't, than a doctor can. It can look at 100 million of those and have all of that data to try to make decisions, whereas a doctor maybe has a couple hundred and doesn't really remember them that well.
And have all of that data for every single decision. Not just like, oh, I remember the 100 that pop into my mind when I look at this particular mole and think, oh, this might be melanoma. It can literally check every melanoma that's ever existed that a picture has been taken and go, here are the numbers I got on how well it matches with it's possibly an irregular, it's an irregular proliferation of cells. Like
the mindset... This might be getting a little far ahead, but we're kind of wrapping this episode up, I think, so it's okay for us to pontificate a little bit. The mindset that is the problem here is that I think most people are unwilling to accept that their life is determined by mathematics. Your life is determined by patterns, and patterns that existed before the thing that you're doing right now, things that happened before. And so a computer looking at patterns of history is able to accurately determine the future way better than you can.
I think this is sort of Sam Harris's angle on the idea of predetermination. Like, I don't think he says that everything is pre-written, but it's predetermined in the sense that you can't make any other decision but the one that you make based on your circumstances and your algorithm. We are not actually possessed of free will in the sense that, every decision feels free and feels infinite, but you couldn't have done anything but what you do in a situation ever.
The interesting, right along those lines, one of the most interesting things for me when I was, as I've like learned over the years about artificial intelligence and computation in the universe, and this, you hear the concept of like, do we live in a simulation? Is the universe just a big computer? And a really interesting thought experiment, we probably brought this up before, but in all this effort to reproduce reality, these video games and physics engines and stuff, we don't do it perfectly, right? Like hair on characters in games, you still don't have millions of hairs. We just can't do it. We can't calculate that much information yet. And to mimic the universe exactly, to actually be able to, for instance, calculate where a hurricane's going to go, you need to know where every single atom in the Earth's atmosphere is and the direction it's moving and the energy it has. And to do that, you need something with the computation power of the universe. You need to be able to store information on every atom. So we can never build a computer that has more access to information than the universe. And the universe just
Unless
is
it would just look like the universe. Right.
Exactly. And so
that's what we're talking about when you talk about this intelligence layer, right? Like the bananas part of that is we are working on algorithms now that we're sort of like, so I think back to medicine, the next wave is going to be if people trust the computer because they have their head around everything we've tried to explain today more than the doctor, what's the doctor supposed to do? And I think the answer brings us full circle to the question of doctoral theses and PhDs and stuff, right? They're going to look at one mole their whole life. It's going to be like, I want to be a dermatologist. And the tradition is the first time you bump into a melanoma, you look at just that melanoma for the rest of your life. And you put the data that you ascertain into a computer, and it uses that data to make decisions for everyone else based on their health for the rest of their lives. Right? So like, it's not that people go away. They'll just focus on different things because you can't match the ability of a computer to recognize a melanoma. But that's a giant shift for like what we expect doctors to do. But what do we do once you hit that point? Like part 3 of this is try to talk about what do you do once you hit a point where you're like, oh, the doctor's not using the robot. I don't know if I trust him.
Of course you don't.
He's not using the
It's
droid.
like the fucking instant replay in sports. Why do we trust a stupid ref when you can go look at a screen and see what actually happened?
Right.
It's absurd. As a non-sports fan, it's freaking stupid. What a dumb... I get that, maybe it wastes a little bit of time, but the announcers on TV are seeing it while the ref is making all this pomp and circumstance about sticking his head in the stupid replay machine.
The problem is that committing to what would satisfy you in that circumstance would make the random number generator less complex.
Are you referring to the sport as the random number generator?
Yes. But I think that's a pretty good place to get out, right? I mean, that's the conversation for part 3. What do you do in a world where what we just explained is inevitable? They're applying this stuff already. There are already reinforcement learning algorithms unchained, learning things about the way you behave on Facebook.
Well, I want to be clear about I want us both actually to throw out a little bit of our own philosophy at the moment on this, because this is kind of turning into what is the point of our podcast. Like we keep coming back to the same stuff, this reproduction reality and this rapid progression into a time period where we don't know what's going to happen anymore because something new is coming online in the universe. And I want to be clear that we don't know what to do right now. And machines are not better at everything. And so I think a lot of people, when they're just chatting with me and probably listening to our podcast, they're like, they probably get a little bit of, these guys are crazy. They like really want computers to take over and just dominate everything. And I do. I think it's interesting. I also think it's sort of inevitable at the moment. But at the same time, it's really important that we figure out what's going on and understand these technologies, understand their applications, and understand their limitations every year, every week, every day right now, because it is happening really quickly. And we need to respond correctly. We need to not let the computer decide if it's cancer, if it's not making the decisions right. And we need to let it as soon as it can. We owe it to ourselves to be familiar with these technologies so people can make good policy. And I think it's very short-sighted to say like, oh no, a human always has to be involved with these things. Like, doesn't make any sense. Humans make terrible decisions.
My response to that is I think people should be duly terrified, and they're not. Like, because if this is what Elon Musk is talking about when he talks about unleashing the demon. If we don't regard this in the right way, whether it's how we let it do things or how we behave, how we incorporate it into our life as an inevitability, like stress is currently, and you meditate to deal with it or whatever, you do yoga, like it doesn't end well for us if we don't take the inevitability, the possible danger, and how to incorporate it into our lives seriously. Like if you keep just going, oh yeah, whatever, computers, ha ha ha, like Pong, like no, like the universe, right? Like I don't
motherfucking universe.
Like the way
it renders trees in very high fidelity.
I mean, like, is that a? I mean, but do you see what I'm saying? Like philosophically, I don't want to say people should be terrified, right? But I do think a lot of this, like you were saying, is inevitable. And I think the conversation needs to happen about what do you do? What
is our place?
Yeah, exactly.
Almost, right? Because part of where we always go with this stuff too is something else is driving this. It's not the universe is creating these technologies. The universe is creating computers. We like to think it's humans creating them, but it's not really. It's those patterns that were in place a long time ago that are creating computers. And what is our place going to be in the universe in 100 years? And what happens as those computers become sentient creatures?
And here's the thought exercise that I tend to use more as a conceptual thing than as something that may actually come to exist, because I don't know what the value of privacy is. But what if privacy went away tomorrow? Like, what if you woke up and it was just like, oh shit,
I would be so happy.
anyone can know anything they want to know about you. Like they are tapped into your brain. It's just straight up, no more secrets.
There'd be
like,
no more war.
What would you, I don't mean like,
of it.
but how would you proceed through life? Right? Like what would change? And we're talking about that scale of shift.
It's a really interesting topic.
It becomes a question. It's not just like, how do you do your taxes? Like, we're not talking about a better calculator here.
I think privacy is a fundamental condition of being human. You're right. If that goes away, like all kinds of things, right? All your insecurities are no longer. Who cares? Why would you be insecure?
What it means to be a human is a completely different thing if we suddenly lose privacy, right? Like, but you've got to consider that because you're talking about a being, if you want to talk about artificial intelligence, that is interconnected. It doesn't have privacy. Like, because we wanted to be all connected up, it's connected up, right? Like this is the shit in part 3, right? Where it's like, I'm deliberately going down directions that I feel like are more popular, philosophically speaking, because I don't want to go off the ledge into what goes into part 3. I think it's irrelevant to talk about the morality of an AI. But that's a completely different conversation. That
there's so much to talk about, and this might need to be episodes 3, 4, 5, and 6.
This is why every time we do this, we end up updating the mission statement for our podcast, right?
I think our mission. I want to like really address our mission statement in episode 3 of this too, because I think we're on to what we want it to be, and I think it's a unique period in history. And in the history of the universe, and we get to witness it and do a podcast while it happens.
Right. We get to talk to people while it happens and hopefully have them talk back to us. I expect to get a lot of angry comments from all of my relatives that are doctors.
I can't wait. Sorry, everyone. We'll go somewhere else for our diagnosis. I can't wait to have our first AI guest on.
Yeah.
Who's it going to be? I hope it's a sexy robot.
I do hope it's a sexy robot. But a robot wouldn't hope that it's a sexy robot. So it would make a better decision, I think.
A robot don't care.
First,
depending on what that robot's goal was.
Anyway, so I hope after this one, you have a better sense of sort of where technology is now in our effort to answer those questions from the first part. And why what we're looking at is like a paradigm shift in behavior and communication. Like what we're bringing online with greater swiftness than what got us to this point, like is now a mechanism for actually handling all of this knowledge that we made infinitely accessible and telling you what to do based on that data set. Making the decisions that you make every day when you're like, I don't know, like, let me look at the label on this food. Like the algorithm will just know how your body works, how it processes things, and what you should eat. And it's going to be better at knowing that than you will ever be by going, I don't know, I don't feel so good.
And it'll make you reevaluate.
It'll make you feel
what
good.
The
you
point
never
is
will go.
Of doing those things,
right?
Too, right? By removing our choice as a human to make the decision as to what to eat. We all of a sudden have to reevaluate. Wait, what was the point? Was it to be skinny? Was it to be healthy? Was it to feel good? Was it to look cool? Was it to feel important? This next episode's going to be really fun.
It's so hard right now to not just jump.
It's going to be 6 hours long. We got to cut this shit off. I want to pimp a couple articles real quick that our friend Pat shared with us, who is super supportive. He's awesome. He's a really good buddy of ours that we grew up with. He shared these 2 AI articles with us called Wait But Why. Wait But Why is the website, waitbutwhy.com.
Yeah.
They're called the AI Revolution. Really, really interesting articles, really dense. They probably take a couple hours at least to read. They're both like 10 pages.
What we just ran through is like a paragraph of one of these pieces. Like it's a really well done overview of everything that we were covering.
If this episode and episode 1 were interesting to you, you should definitely read these articles. We'll post them. I think we probably already did post them on Facebook. We'll post them again. Right. We'll post them with this cast.
Word. But thanks for hanging out. Keep talking to us on social media. It's Engineering Pod.
Like us and rate us on iTunes, please. If there's one thing you do today to make us happy and thankful,
rate us other people involved in the conversation.
iTunes.
Yeah.
Or share this.
Rate and review
our
us on
podcast
iTunes.
with somebody. We'd love it.
Or just share the podcast.
We're really enjoying doing this.
Thanks for hanging out for another one. I'm Adam.
I'm Brian. Have a predetermined day.
Good stuff.
They don't know what I know. They don't know.
Damn it, I screw that up again. That's the fourth time.